Choosing of the K. How we can choose the accurate K, the reliable K, the best K value. How we can decide it. What is the procedure? Why it is important to choose the right K. Why you need to be very careful in choosing the K value. Let me show you graphically here. Look, this is my KNN model. It is in a two-dimensional view. These are my two data classes, data 1 and data 2. I have this new data here. I have given this new data here. This is my new data. So I randomly pick K equals to 1. I'm just showing you that why the K value is very important. Now look at here. You might be confused that why I have two data points from data 2 into data 1. It is not an issue. You may have some data points from data 1 into data 2. You may have some data points from data 2 into data 1. It is not a big deal as long as the label is clear. Look, data 2 has its own label. Data 1 has its own label. So they are clear now. Therefore, it doesn't affect the machine model. They may have some mixed data points. It's not an issue as long as the two classes are different. Their labels, their information, their identification are different. It has its own identification. This has its own identification. So these two data points stand with their own identification here in data 1. They belong to data 2, no matter if they are here or here. Now look, this is my new data. So I randomly picked K equals to 1. If you have K equals to 1, it means that you need one nearest neighbor data point. What is the one nearest neighbor data point? Obviously this one, yellow one. So this is the one nearest neighbor data point. The nearest distance is from this point, not from here, not from here, from this one. So if K equals to 1, you have to pick only one data point. Therefore, I picked it here. Now you have to check that which category of data has more nearest data points. Obviously data 2. There is only one nearest data point. So the new data has been classified as data 2. If you take less K, it will be sensitive to noise. This KNN model is sensitive to noise. It's not a good model. Look, the model may do misclassification here. Because remember, we can also take the distance from data 1 as well, here and here. If you take only one distance, K equals to 1, it has been classified as data 2. But it's not a good way. The model is not in a stable condition. It is sensitive to noise. The model will be sensitive to noise. But what if I take the same model, but this time I'm going to pick 4 nearest neighbor points at K equals to 4. We can say that the data has been classified correctly as data 1. It is a reliable. This KNN model is a reliable. It is in a stable position compared to the left side. Look, this time I have K equals to 4, which means that I will pick 4 nearest neighbor data points from both of the data classes. 3 points from data 1 and 1 point from data 2. So we can say that data 1 has more nearest neighbor points, 1, 2, 3. Therefore, it has been classified. This new data has been classified correctly as data 1. So this KNN model, this K nearest neighbors classifier, this KNN model is good, reliable, stable compared to this one. As I told you before, that the larger we have the K, which means that the more nearest data points we have, better will be the classification. The less we have the nearest neighbor points, the lesser will be the classification. If you have less data points, there is a chance that the new data may be classified wrongly. But as you can see here that it is sensitive to the noise. The model is not in a good position. It is not in a stable position. This model is good. But make sure too much nearest neighbor points. For example, if you pick K very large, which means that if you have a lot of nearest neighbor data points, there is a highly chance that you may misplace the locality of the data points. For example, if you K equals to 500, 1000 or 2000, which means that I will have 1000 or 2000 nearest neighbor data points. Now the machine will be confused at some stage. You may pick the data point which is not actually the nearest one, because there will be a lot of confusion. Everything will be mixed. We have a lot of data points, so there is a highly chance that the machine may pick the wrong data points which wasn't supposed to be taken. But as I told you, there are a lot of data points. There will be a lot of data points where the model will be confused. So very large k is not good, but very small k is also not good. As you can see here, that it is sensitive to the noise. You have to be very choosy in selection of k. Correct k, accurate k is very important for the KNN model. I hope you got the point now that why choosing of k is very important in k nearest neighbors classifier. You should be very careful. Look, there is another way, there is another technique which is called cross-validation technique. Cross-validation technique may also be used to choose the k value in k nearest neighbor classifier. This is another way, this is another technique which is very helpful in choosing the correct k, the accurate k for the KNN model.